Hey guys, this is Jesse from Project FDL. Today we are going to build an FDL-3. This version of the FDL-3 is the one that we affectionately call the FDL-We. And that is because it has a short dart nose, which is the front half, and a semi-auto tail, which is the back half. So this is the shortest configuration of noses and tails that you can get on a FDL-3. This FDL-3 happens to be for our good friend Jangular. As you guys can tell by the colors, this is probably something that he's going to call like a FabU FDL or something. We're real excited to build this for him, and it'll be cool to watch it come together. So let's get started. Let's walk through the tools that you're going to need, some of the electronics components, and then we'll take a quick tour of all the prints and just talk about everything a little bit before we start putting stuff together. Let's go. Okay, so tools. Let's get some of this stuff out of the way. Okay, so the tool set is real similar to what it was on the FDL-2 and even the FDL-1. I've actually tried to pare the number of tools that you need down over time, so it's actually fairly slim. Your most important tool is your number 2 screwdriver. You will see me use an electronic version of this, but because you are screwing metal screws into plastic, until you are accustomed to how tightly you can tighten those screws, I would highly suggest that you use a hand screwdriver still. After that, you have a 2.5 millimeter hex key. You could use the usual L-shaped hex key. I have a couple sets of these drivers, and I really enjoy these. On older versions of the FDL-3, you would need a 1.5 millimeter as well, and then on the full auto version, which will happen in another video, you'd need a 2 millimeter version as well. I have a 3/32 hex driver. Yes, there is mixed imperial and metric. One last thing is either 8 millimeter, or I found that a 5/16 wrench works pretty well. I have a ratchet version of this, but for the sake of clarity in the video, I'm just going to use a hand one. And that about covers it for necessary tools. I like to keep a small flathead screwdriver available for kind of helping me guide wires and things like that, in addition to a set of needle nose pliers. And you may occasionally need an X-Acto knife just to clean things up a little bit. And the last thing is Loctite. So anytime you are putting metal screws into a metal object that is going to vibrate when you use it, you probably always want to use Loctite of some sort. We choose to use the blue Loctite. The blue Loctite is a non-permanent Loctite, so it'll help screws from backing out, but you can still take them out. So we get these sticks of this in the shop because it's much easier to just kind of poke screws down into it. And we found that using the liquid kind, like this, tends to leave little liquid drops everywhere, and then people get blue dots on their blasters. So we've moved over to using a stick. These sticks are excruciatingly expensive, but for the convenience for us we use it, but I would suggest that you get these little tubes of blue Loctite. I've seen real small versions of these sold too. So that's about it for tools. Okay, so let's talk about some hardware that you're going to see. Just like on all of the other FDLs, you will encounter a bunch of 632 machine screws. These are usually Phillips, but you are welcome to replace them with hex or whatever you want to replace them with. In this particular version, you are going to see a 3/8 version, a 1/2 inch version, a 1 inch version, and a 1 1/4 inch. And then to mount motors, we have these M3x6 hex screws. So these are metric, and these just mount the motors to the cage. So we have these long 440 hex screws, and the nylon lock nut to go with it. So I use these to basically compress together different layers of the front of the blaster. You'll see about 8 of these. Every version has these little pen screws. I get these out of InkJoy pens. Specific to the semi-auto version, you have these two dowel pins. So these will go through the gears that make up the pusher mechanism, and the gears will rotate around these. There's two. And then a slightly larger spring, and this is your trigger return spring. So this is what pulls the pusher back after you let go of the trigger. And then also two thumb screws, so those will hold your battery door in place. And I believe that's it. So let's talk about electronics. Okay, so the electronics in this blaster are going to be fairly simple. The semi-auto version of the FDL-3 doesn't have all of the pusher motor and the screen and all of the stuff that makes it full auto and select fire and all of that. So the semi-auto version is much more simple. First up, you get this kind of loom piece. So the way that the FDL-3 is assembled is I actually solder all of the power board, the ESCs, and the motors all together. And then the way the front goes together, you can just kind of thread this through it. It is on the 40 nose version. I would slice these and I would put 2.5 millimeter connectors in there. If you get that and you feel like you're going to change the motors or you're going to do a lot of maintenance on your blaster, it may not be a bad idea for you to do that as well. It would just be a clip there, connectors inserted, and then heat shrink over them. But this, like I said, includes a power board. So this takes power in from the battery. There is a MOSFET on here that turns the power to the entire blaster on and off. This little green board in here is what is called a BEC, or a step-down converter. So this takes battery voltage and it drops it down to 5 volts. That will run the Arduino or the screen in the full auto version. You have two BL-Heli32 ESCs that attach onto this power board. You could easily use any other ESCs if you're building something from scratch. And then we have two Lumineer 2400 kV brushless motors. Okay. Next up is in the back. So this is a trigger PCB. So this holds this small Arduino Pro Mini. It's one of the smallest Arduinos that you can get. There are a couple that are even smaller, but I really like this one. I like the form factor of this. There are pins soldered to one side. We only need this side of pins, so they're only on there. This connects into this board, and this goes only in the semi-auto version. So this is your speed knob, and then there is a limiter knob inside. So this knob is only accessible with like a flathead screwdriver from within the blaster. There is a lockout piece that you can put above this, and then use this as your like tournament lockout. And then this is, 5 volts and the data feeding to the ESCs in order to turn them on and off. So that's essentially the heart and brain of the back of a semi-auto FDL. Other little things are a voltmeter, your rev switch, and a power switch. And that is like the entirety of a semi-auto FDL blaster. So I don't know if I mentioned, but this big loom is the same thing in every nose. So this is applicable to a short dart FDL, a regular dart FDL, and the 40 mag version as well. Okay, so let's go over some of the prints real quick. I don't want to spend a ton of time on this, but I do want to look at them fairly quickly. So the front portion is, here is your mag well, and this is what a Talon mag would fit into. You have your upper and lower cowls. You have the outer portion of your barrel up front. So this is the piece that your motors mount onto, and then the wiring runs through it. You have the inner section of that, so this makes up the geometry of the cage. And then your muzzle piece goes inside of there, and then this sandwiches between the rest of the cage. You have your mag gripper that goes on the front. This little housing, this is the ESC housing, so that power board slides into here, your ESCs go in here, and then you have a cap piece that holds it all into place. And that makes up most of the front half of the blaster. The back half, you have your underbelly piece, which is so cute, because on the big one, the underbelly is about twice as long. You have your handle guard, which would ultimately slide into there. You have your pusher guide pieces. So this is like the base and the tower. These two go together. That piece that I had that had the knob in it goes inside of this, and then your pusher goes inside of here. You have your handle core and your two handle scales that make up your handle. Stock attachment, gear plates. So your gear plates, these are your flywheels. The gear plates are what's going to hold the 3 gears that make up the pusher mechanism. And we'll get into that in a little bit. Your 2 side panels. There are holster versions of this available. Your battery cap. This is also called cap mid in the files. 2 top rails. Your rear cap, which is going to house your power switch and your voltmeter. Your mag release, and then there are a couple little bits and bobs in here that make up your mag release. Rev switch, trigger, and paddle are in there. And then the last thing is your pusher piece. Okay, so let's, I'm going to put all this away, and then we're going to start with the nose, or the front half of the blaster, and then we'll do the back half. Okay, so to start, you're going to want to grab your power ESC and motor bundle, or loom, and 8 M3x6 hex heads, and your Loctite, and your 2.5mm driver. Now, you're going to want to be careful about which side which motor mounts into. So what I like to do is I like to lay this down so that this green PCB, like your voltage regulator there, is facing you. And then take your 2 motors and establish which is the left and which is the right. And then you're going to take your 2 outer barrel pieces, and for reference, on the short dart version, this is your outer barrel and your magwell caps combined into one piece. So like on the full length version, this is a separate piece than this. But because this is so short, it makes sense for it to be one piece. When you look at these, outside of your motor mount holes, there are 1, 2, 3, 4, 5 other holes. On one of them, the opening is circular. On the other side is hexagonal. So these hexagonal portions will accept those nuts, which actually I forgot to mention. You're going to need 5 of the longer 440 hex bolts and matching nuts to go with them. Okay, so when you are looking at these pieces, the piece with the circular holes goes on the right side of the blaster. So set that down there. The piece with the hexagonal holes goes on the left side. So again, before we do this, I can see this green voltage regulator right here. My battery connection is off to the right side. I've established my left and right side motor. I've established the left side barrel, or the left side motor mount and the right side motor mount based on circular holes on the right, hexagonal holes on the left. Now we're going to start mounting the motors onto these holes. So if you were using the tube of Loctite, you would just put a very small drop right on the end of the screw. What we usually do is just take and kind of poke the screw down into there and get a little bit of Loctite on the screw itself. Put through the top one. Now underneath here there is a wiring channel, so you're going to want to line the motor up with that wiring channel. What I usually do is get the top screw in, just a couple of threads in. And then use the bottom screw to get the motor mounted in the correct orientation. So, and then as I put these in, I'm just getting them kind of snug, and I will go and I will do the final tightening once all four are in. Okay, got all four, so I'm going to snug them up pretty good. Now keep in mind you are still tightening into plastic, so you don't want to over tighten these, but you are tightening into a metal motor, so you can get them pretty snug so that that motor doesn't vibrate around. Okay, so once you get the motor on, you might as well put the flywheel on it too. So take this nut off if it's not off already. On the bottom of the flywheel there are two notches on either side, and the intention of those is to rest into these openings on the outside of the motor. So you're going to want to slide the flywheel over the motor, and then you may have to hold the bell and twist until it does that last little seat. And then once it's seated on there, you want to hold the flywheel straight . Put the nut on. Okay, once the nut is snug down against the flywheel, I usually wrap fingers around it and give it a good tightening. You want this pretty tight, but you don't want to tighten it so much that you are deforming the flywheel itself, and or you don't want to strip the actual post on the motor too. I've actually done that before. So tight, but not over tight such that you are stripping things out. Okay, so that same whole process again on the left side motor. Okay, so once you've gotten the motors mounted onto both sides, we can construct the rest of the cage. So grab your two inner barrel pieces and your muzzle. There is a channel on the front of both of these that the muzzle rests in, and then the two of them sandwich together to make the inner geometry of your cage. Now if you look at the end of this, there's a semicircle and then kind of a flat spot on there. So the flat spot is the lower side of the blaster, so you're going to want to hold this such that the rounded portion is facing up. And then you take one side of your cage on the right side, and then this flywheel goes on the bottom. So we slide it in like that, making sure to not pinch the wires. And then the other side is the same thing, except On the other side, the motor is on the top instead of the bottom. So it's kind of a unique cage in that like both motors aren't on one side, they're flip-flopped. Okay, so once you have them sandwiched together, you're going to want to put it down on one side. Take one of your long 440 screws and slide it down through. Do both of these. Now sometimes these holes are fairly snug, and I actually have like a little tiny ball peen hammer that I will tap them into, or you can screw them down into place, but just know they are not always super simple slide through like that, because everything is supposed to be held together very, very tightly. I don't want like things to be loose. Okay, so but once you get both of those through, put a nut in on the other side, and what I will usually do is just screw these in just enough to catch that nut, but we're going to wait until more of the blaster is together to actually tighten this. Okay, so once we get that, we want to keep these kind of up here. Now, both of these wires should be in these channels, and you can kind of use your hand to hold them apart. And then you can take your magwell and slide it in there. So it should seat itself in the angles on here and in there. So once you get that slid in, there's 3 more of these screws. There's 2 on the back portion of the cage, and then there's 1 all the way back here. Nuts on the other side. So this is the 3/32 hex driver. I don't know if I mentioned that before. Okay, and now that I've gotten all of those nuts in on the other side, I'm going to go ahead and tighten these up. So these can be fairly tight, but there's no reason to tighten them super hard. You're just wanting to compress the cage all together and get everything lined up properly. Like I mentioned before too, these 2 pieces are separate on the full length dart version. On the full length version there is a lower magwell and an upper magwell too, but we'll cover that in the video specifically for that. Okay, so now you have your magwell, you have your cage all built and everything. We just need to clean this up here. So grab your ESC housing, and if you look at this, you can see where this board slides in right here. So I will usually pick these up in the air like this, and you're going to need to hold the wires forward as you slide it in. And then you can kind of like sweep that underneath. And this sits on top of the blaster. There are notches on either side that the wires feed through. Okay, once you get that there, then you want to kind of tuck your ESCs down in here. Ideally you want the lettering and stuff facing up, because this is actually like a heat sink on top of the ESC. It's not a big deal, it just would be ideal if that was facing up. So just do whatever you need to do to kind of get those tucked in. These white and black wires can hang out the side for a minute. There you go. So once you get those in place, kind of hold it down with your fingers and then put the cap over the top. And the white and black wires can hang out through the sides of this cap. And then it's 2 1-inch machine screws that go down through here. There you go. And then the black and white wires attached to the 2 sets of double pins up front. And then you want to align the black wire with the large black ESC wire underneath. So for reference, if the blaster is facing that way, the black wire should go on the left side of each of these. Right in there. There, and then you can do whatever you want to kind of wire manage these, but you can kind of tuck them in there. Yeah, kind of nice. Okay, and then the battery wire hanging out should kind of loop back and then forward again. And then there's 2 channels that these wires can pop down in that holds them in place. There you go. And then that is most of the front half. I do have the cowls out here, but I'm not going to put the cowls on yet, or the front grip, because when we put it together it's going to be easier to test once it's all together if the cowls are still off. So we'll set that aside for a second. Okay, so let's start on the back half. Get some of this stuff out of the way. So you're going to want to start by grabbing your handle core. You can grab the handle scales, but keep them to the side for now. And then you want to find your 2 gear plates. So these will sandwich together like this. It will go around the top of the handle core. And then you have 3 gears. 3, your pusher, trigger, rev switch, actual rev switch, pins. Okay, let's get this started. So first thing you want to do, and if you have printed this, these little gears need to be super accurate. Like if you put this together and everything is not fitting properly, like you want to be prepared to kind of clean some of the gear teeth out and stuff. Okay, first thing, you want a 3/4 inch machine screw, and you want to slide that through your smallest gear. And then if you find the right side gear plate, that's this one, this screws down into that plate. So what you want to do is you can tighten that down, and then you want to back out about 1/4 of a turn. Just enough so that that gear spins freely. Then you want to take your 2 dowel pins, put them in that plate so you get that type of thing. So these 2 gears, there's one with a kind of skinny gear, and then there's a long, smaller one on top of it, and then there's a more shorter one. This one goes with the smaller gear facing down, and that just slides onto that pin. So set that there for just 1 second. Take your handle core, and then you have your trigger. The trigger needs to be inserted into here. So there are 2 rails that the channels on the trigger ride on, and if you very carefully and gently pull the handle core apart, you can kind of coerce the trigger down into there. That should slide very freely. I would then take your trigger spring. There is a hole in the back of the trigger that this slides in, and then there is a bump on the back of the handle core. Once you get that in, that should work nice and smooth. Be careful, this spring could still pop out of there. But yeah, once you get the trigger into place, take this setup, and this slides over the top here. So you see when you pull the trigger, it turns that lower gear. Just kind of set it there for a minute. Now your pusher, so you see the gear teeth, it's going to go down inside of here. Okay, I was wrong before. The larger gear faces down. Okay, so in order to get this lined up properly, you have to pull the pusher all the way back. I mean, when this is seated, this is the pusher all the way back. And actually what you want to do is let that open up just a little bit, so you're pulled back just a little further than it's supposed to go. Once that's there, then the other gear should just pop into place. You can start seeing how that works. Now it may be kind of gritty and grindy at this point. This doesn't usually situate itself until everything is together. You may want to add some lube inside of here too. I have a tube of super lube sitting around that works pretty well. I've tried to tune this to the point where you don't need lubrication inside of here, but you can get in and lubricate it pretty easily later. Okay, then you want to take the other half of those gear plates and put that on there. Then you take two 1 1/4 inch machine screws, and those go in there. Tighten that down. If you get that all in, that should feel pretty good. Again, this is the moment where you know, like, if this is going to be smooth or not. If you don't think it's going to work out well, you can start putting some lube in there. His feels pretty good. I like that. Okay, so next step is your rev switch. So you have this long orange cable that is going to go through this channel here. And this is where I may pull out my flathead. So the intention here is there's a bunch of corners and stuff that this goes around, and there's things that retain the wire down in the channel. So sometimes it's a little fishy to get it all in. There you go. And then the switch itself slides into this opening right there. And then you can pull the wires up and then tuck the excess down inside. Let's put on the handle scale on this side though. So this goes on here. And then it's a 1/2 inch machine screw right here. And then you have one of the long 440 bolts again, and that slides through up here. And this helps get everything aligned between the handle scales and the core and the gears and everything. It just helps to line everything up. Now I will put his rev switch back in. And this wire needs to tuck up into this little channel here. And then your other handle scale, slide over that bolt. Make sure that this wire right here isn't pinched anywhere. And then you have another 1/2 inch machine screw that holds that handle scale on. Now, the design is intended to have one of these nuts right here, but I found that if you leave that nut off, if you take your side panel off, you can get to your rev switch and everything really nicely and easily. So I actually tend to leave that off. Okay, so now you got a solid handle. Let's finish the rest of the back half. So grab your voltmeter and your power switch and your rear cap. So on the rear cap, the smaller of the two openings is where the power switch goes into. The other one is for your voltmeter. So put the voltmeter in first. Now, if you look, there's 2 holes on the rear cap, and those face towards the rear of the blaster. The wire on the voltmeter actually needs to go out the back and then kind of fold down. So go ahead and put that in first. There is a little tab inside of this that will hold the voltmeter in place once you get it situated. Okay, and it should kind of click into place. Once you get the voltmeter in, then you put the wire from the power switch through, and I usually do this with the line going to the right, but you can do it either way, it doesn't really matter. You pop that into place. Okay. You want to kind of string the wires out through the front. Set that aside for a minute. Grab your board with your Arduino. If the Arduino is not in the board, it goes in this kind of black header piece, and it faces up in the direction that the blue limiter knob is. Then grab your two pusher guide pieces. So you have the lower one, which has a serial number. Jangular's serial number is 0110. And then the upper piece, which is called the pusher guide tower. The idea is the lower one, the board goes into, and then the knob sticks out the bottom. And then the upper one has the openings in it. So this is the opening right here that you would put a screwdriver down and adjust the limiter. There is a piece that can go in the side that can act as like a tournament lockout switch. Then there's an opening just in front of that where the 3 wires that go up to the nose will pop out, and then the pusher slides in the opening there. So the first thing you want to do is take your orange wire from your handle for your rev trigger, and then feed it through the back opening and down. And then that will plug into the 2 pins on the board. Then you take your rear cap that has your voltmeter and power switch wires, feed them through that same hole that the rev trigger went through, except you're going to feed them all the way through out the front. And then once you get them out the front, then they go up through that opening like that. And then you want to leave, I don't know, about 3 or 4 inches of slack there, maybe a little less. And then if you look, so the hole that your screwdriver would go down through, there's a little bit of a casing around it. These wires should be in the slot between that casing and the rest of the guide. That. And then your rev switch wire, you want to kind of fold forward and do like a little loop-de-loop thing. And then the red, black, and white goes up through that same opening as the other two wires. And then you can push the board up into that piece and make sure you're not pinching any wires and that everything is nice and cleanly routed. And then the bottom piece goes over the speed knob, and then it's 2 1/2-inch machine screws to hold this whole piece together. Okay. Now, there should be just enough slack in this orange wire to be able to put the pusher into place. And then the other 2 wires need to go on the left side of the blaster. That goes there. And then there are 2 channels on the back of these gear plates that the rear cap slides on. So you want these wires feeding out the front of the rear cap, and then it slides over the top like that. Okay, so then you can kind of tuck these wires into place here, however you feel necessary. You can put a zip tie on them if you want. Whatever works, whatever gets them nice and clean. And then we're going to put the left side panel partially on. If you look at the side panels, there is one opening that is a little bigger than all of the other ones, and that is the one that your thumb screws go down through. So that faces up on the panel. That's how you know left versus right. So we're going to put this on here, and then we're going to put 3 3/8 machine screws just along the bottom of that for now. And then in the back, grab your stock attachment point, and there's an opening on the front of that that the pusher slides into, and this kind of puzzle pieces into place like that. And then to hold that into place, on the lower one you have a 3/8 machine screw, on the upper you have a half-inch machine screw. The top one's longer because it goes through this rear cap piece into the stock attachment. Okay, and then flip over and same thing on the other side. Okay, let's put the mag release and the handle guard together. So grab your underbelly and your handle guard. And then you have your mag release block, lever, paddle, link, and catch. So you have the little pen spring. There's an opening on the top and the front of the mag release block. You can slide the spring down in. And then your lever slides into the opening on the catch. And then you can use either a screwdriver. I actually use a small hex key here to compress the spring and then slide that in. And then the link piece, this is the piece that links the lever to the paddle. On the side of this, you'll look there, right here, this notch is angled, so that should angle up. And that just kind of sits in there like that. And then this slides in here. And then it is a 1-inch machine screw that holds that whole block in place. There you go. And then once you get that together, the paddle just rests into the opening on the inside of the handle guard. That should operate nice and smooth. And then the bottom of the handle guard will slide into the opening between the 2 handle scales. Now keep in mind this is going to be a little floppy here. but then it's a 3/8 machine screw on either side of this. Be really careful because this can tend to strip out here. So you just want to kind of hold this in place. Flip over. One on the other side, and you are good to go. So besides the battery cap, that is the entire back half of that blaster. Okay, so now we are going to take the two halves and actually join them together. So here we want to make sure that we have enough wire slack in order to connect up to the front. So you want about, I don't know, 3 inches or so. It's just enough to go up and then inside of that front compartment. And then when you get the two halves ready, they just slide together like that. And then it is a 3/8 machine screw here and here on the two panels, and then a 1/2 inch on the underbelly underneath. Okay, flip over, same thing on the other side. Cool. Alright, I'm actually going to grab a stand, put this on that for the next step. Okay, so now we want to connect these wires to the front. If you look inside of here, and I will probably take a picture, but there are 3 different connections on this power board. There is one for your power switch, one for your voltmeter, and then one for this white, red, and black wire that comes from the back. On the far right is the power switch, and there are letters on the board that tell you which one is which, but again, I will take a picture so that you can see inside of there. The first thing you want to do is take these wires and get them up inside that compartment. So that helps clean this area up right here. And then I usually plug the voltmeter in first, and plugging the voltmeter in first will actually kind of clamp these wires into place. When you plug the voltmeter in, and this on the full auto version is just a 12 volt wire that goes back to the rest of the blaster, the red wire needs to go on the right side of the blaster. This is absolutely critical. If you flip this wire around, it will blow this front board. If I put power protection in there, there's less power that goes to the rest of everything, and it complicates the rest of it. So just red wire goes on the right side of the board, don't mess it up. Then right to the right, the black wire that is the power switch plugs in. And then in front of those, this white, black, and red wire plugs in with the white wire facing towards the front of the blaster. There you go. And once you get those in, you can kind of tuck any excess that you have towards the front. Now, at this point in time, we are ready to power it up and see how everything looks. Okay, so I'm going to grab a LiPo. So these take a 3S LiPo. I would suggest if you have some other means like a computer power supply or like any sort of power supply that will give you 12 volts besides a LiPo, to use that to test this. I am pretty confident that this is going to work. I've done this a few times. So I'm just going to go ahead and use a LiPo to test this out. So it goes up here. Make sure your power switch is off when you plug this in. Cool. So everything booted up. Check the flywheels. They appear to be spinning the correct direction. Those should already be set up spinning the correct direction if you bought a bundle from us. But yeah, everything looks good. Check your knobs. Cool. He sounds good to go. So let's take the battery out and we'll finish the couple other little external pieces. Okay, so we can go ahead and put the top cowl piece on. There are these kind of ribs on the front, and there is a notch in the front of the cowl, so that slides over that. And then there are two holes right here that hold that in place. That is 3/8 machine screws on either side. And we'll actually throw the bottom cowl on at the same time. Okay, flip over, same thing on the other side. Okay, and then your mag gripper goes underneath here, this, and then is a 1/2" machine screw on either side. Okay, back on the stand. We're going to put the mag weld, or the battery cap. This is also called the cap mid. If you look, there is a little notch on one end of this. That little notch faces forward. Okay, and then we can put the two thumb screws in. I'm just going to put them in a little bit because I'm going to put the battery back in a second. And then last but not least, we have our rails. So one of these is slightly shorter than the other, and you can tell by the way the holes line up that the shorter one goes in the front. And these are 3/8 machine screws that hold the rails in. Same thing on the back one. And there you go, the Fabu FDL. Let's throw a battery back in it and give it a whirl. Talon mag should go in nice and easy, should fall out free. Cool, feels good. Alright guys, thanks for watching. There's going to be one other assembly video, that is the full length dart front and then the fully auto back. But yeah, thanks for watching. Take care.